did to cut the string and stuff. Okay, so what a radian is, again, is just another way to measure an angle. We're used to degrees, and most of the time, you know, the majority of the time we'll do degrees. But what is it from the center to the edge again? What do we call that? Radius. And when you cut that string, then you laid the string on the outer edge of your plate, right? And you made those marks, okay? So your string was the same length as your radius, right? And this arc length was the same length as the radius, right? And then you were supposed to make a mark around there, and this angle here that was made, that was 1 radian. Okay? And how many did you get around there? You got a little more than 6, right? You got 6 plus a little bit, didn't you? That's what should have happened. And again, I know it was kind of hard to get it just right, but the more that you took your time and tried to get that length exactly right, you would have got, number 8, how many radian angles in your circle? 6, and then a little bit more to get all the way around. Okay? And when I did my circumference, the first answer here, I got 28 5/8 inches, and my radius was 4 5/8. And then I got my degree measure to be 57. Okay, a radian is between 57 and 58 degrees. It's 57.3 or something like that. I'm not positive what it is. Okay, so when we got down to the bottom there, we had the 6 and a little bit, and then 2 pi radians was basically 1 full time around it, which is how many degrees? Yeah, so 2 pi radians is 360. Okay, so what's 1 pi then? 180, right? Just divide both by 2. So if you go to the next page then, if you look at the top, conversion between degrees and radians, that gray box, it says, it's kind of hard to see, but to convert an angle measured in degrees to radians, you multiply by pi over 180. Okay? Now this won't let me write on it. Okay? And then if you convert from radians to degrees, you multiply by that reciprocal, 180 over pi. So that's where that came from, is that last thing, the 2 pi radians is 360 degrees. You can reduce it to pi radians is 180 degrees. So that's where that fraction came from to do the conversions, okay? So I just want to go through the conversions with you to make sure you understand them. But again, just to understand what a radian is, it's just the arc length and the radius are the same measure on all circles. If you do that, you're going to get, that 57, between 57 and 58 degree angle is what a radian is. So, let's see here. What happened to, okay, that's all right. We'll just use that one. So looking at example 1, though, for example, it says, it says 225 degrees, right? We're supposed to multiply by pi over 180 when we go from degrees to radians, all right? So here's how I do it. I just make a fraction bar, and I put pi here and 180 here. And then I just reduce that fraction. Okay. So here's what you can do on your calculator. All right, just go 225 over 180. Don't put the pi in there. I know you can, but I don't want the decimal answer. They never write it in, well, I wouldn't say never. But majority of the time, they won't write it in decimal form. They'll write it in terms of pi, okay? So how do we change from a decimal to a fraction? Math, enter. Yeah. So that's all I do. So example 1 in radians is 5 pi over 4. Okay? So, example 1a, you put pi over 180. You should focus on dividing by 180. So that was what I put in the blank. And write pi after your fraction is reduced. And then I wrote 225 over 180 is 5/4. So the answer is 5 pi over 4. Okay? Example 2, we just do the opposite. Or we flip our pi over 180. So we're going from radians to degrees. We multiply by 180 over pi. What's going to happen to the pi's? They're going to cancel out. Now, some of you are thinking that this is a proportion. If it's multiplication symbol there, it's not a proportion. What symbol's there if it's a proportion? Equals, yeah. Okay? So when I do these, I just cancel those out. And a lot of times, this number in the bottom goes into one of these two in the top. Usually it usually goes into 180. Not every time, but the majority of the time. So how many times does 9 go into 9? 1. How many times does 9 go into 18? 2. But since it's 180, it's not 2, it's 20, right? Then I just go 5 times 20. So example 2 is 100 degrees. Okay? So if we go, and again, to convert, A would have been 180 over pi. Since the pi's cancel, you should only focus on 5 times 180 divided by 9. And 5 times 180 is 900, and 900 divided by 9, the answer is 100. And again, 2 pi radians is 360 degrees, and 1 pi is 180. Okay? So what's 90 degrees? Close. What do I got to do to 180 to get 90? Divide by 2, right? So that's what that is. Okay? So if I look at, let's just look at the bottom 1e. You've got 11 pi over 6. And we're changing it to degrees. Pi's go away. How many times does 6 go into 18? 3, so 180 is 30. So what's 11 times 3? So if it's 30, we just add the 0, right? So that last one on, 1 at the bottom left there would have been 330 degrees. Those answers, I can read them all off to you. Some of you got them all, some of you didn't. That's okay. You guys did a good job trying to figure this out. All I wanted you to do is try. You guys did. A was 180, B was 90, C was 45, D was 135, and then the 330 was the E. For number 2 there, 270. Again, degrees to radians, I just write it like that. 0. A lot of times you get zeros, just cancel. And then what number goes into 27 and 18? 9, right? 3 does, but you always want to try to get the bigger one. All right, so 9 into this is 3. 9 into this is 2. So it's 3 pi over 2 for the 270. For the 60, it's 1 pi over 3. For the 150, it was 5 pi over 6. For the 30, it was 1 pi over 6. And for the 240, it was 4 pi over 3. So what do I want you to know from doing this? Changing from degrees to radians and radians to degrees. Okay? Radians to degrees, multiply by 180 over pi. Degrees to radians. Just divide by 180 and remember to do what in the numerator? What symbol you gotta remember? For radians. What's that symbol up there? Come on. It equals 3.14 pi. Yeah. Okay, so don't forget the pi in your radians. All right. So today I want just to review special right triangles. What are the two special right triangles? What are their angle measures? 30, 60, 90. Oops, I did that one wrong. Correct. You guys are so smart. That should be the 30, according to the way I drew it. So another name for a 45-45 is an isosceles right triangle, right? Okay, so one way we did it was with numbers. Oops. What's wrong with that one? All of it. Where should that have been? That should be on the 45, right? Getting in a hurry. Sorry. So these are the ones in the square root of 2. This was the 1, that was the 2, this was the square root of 3. That was one way we did it. Another way you could say x, x, and x times radical 2. This would be x, 2x, and x times square root of 3. Okay, however, the green way or the red way that you remember is fine. They're both the same. Okay? So we're going to have, I'm giving you a worksheet that you can work on the rest of the class, whatever time you got left, and for homework. But remember, opposite the 60 is the short leg times the square root of 3. The hypotenuse is always twice as long as the short leg. So they're going to give you different sides, and you just got to move yourself around. If I know the hypotenuse, divide by 2 to get the short leg, and then multiply by the square root of 3. If you know the short leg, multiply by 2 for the hypotenuse, multiply by radical 3 for the short or the long leg. If you know the long leg, divide by radical 3, which means you got to rationalize the denominator, right, Autumn? And then double that number for the hypotenuse. Here, if you know one of the sides, you got the other side because they're the same, and then multiply by radical 2. If you know the hypotenuse, divide by radical 2 to find the other two sides. And again, rationalize your denominators. Okay? So, that is just a quick review of that. Tomorrow, we'll go over this little special right triangle worksheet and do a little bit more review. You won't have any homework tomorrow. And then we'll get started on what we call the unit circle on Thursday. There's two sides to this. It won't take you long at all. If you decide to focus on it, it'll take you about 5 to 7 minutes per side, if that long.